Hello dear students, this is our first lecture of BSc or BTech, mostly in BSc second year, that is maybe in some universities third semester or in some university in fourth semester. Electromagnetic theory is discussed, and in BTech mostly in third semester, that is second year, electromagnetic theory is discussed. So many days I could not manage with my time to upload this, and now I'm making the video on vector functions, because electromagnetic theory can be understood with proper understanding of some of the basic requirements of mathematical notations. Now, to talk with vector functions, actually we are accustomed with vector and we are partially accustomed with functions. So first let me tell in brief what are functions. Functions are actually, suppose say you have y is equal to fx, and we have equation given like this: y is equal to, or function fx is equal to x square minus 2. If you have function like this, means it follows some rule that if you give some value of x, in return you get some value of y. All the time we maintain that, and we call that to be a function. If this law is maintained, then we call it function. Then you can calculate value of y by plotting value. Suppose say x is equal to 3, you get y to be equal to 7. If you take x equal to 0, then you have some fixed value of y, and we can easily plot graph of x and y. Now, no doubt this function is a two-dimensional function. Now you might be asking me or thinking about that why I am discussing about all these functions here, because to start with electromagnetic theory, we have to be very clear about functions first and vectors on the other hand, and then combining vector functions, because electric field as a whole is a vector, no doubt, and it's a function of something that we are going to discuss what it is function actually dependent on. For example, suppose say you have a charge. In this figure you can see, suppose say you have a charge here. In case you have a charge here, and that charge is suppose this is my charge. At the center we have a charge here. This charge, or in junior classes you have done, in 12th also you have done, that charge will emit its force in all directions. So in three-dimensional world, we have to consider if there is a force maybe at the center. See, we are taking frame of reference. This is our basic reference where we have a point origin, and here we have a charge. So this is my origin distance, and we have also distance from the charge to the origin, and even here we have three directionals I, j, k, and here we have defined at this point fx, fy and fz respectively. That means the resultant force will be in this direction, the charge will move in, or the electric field will move in this direction. Right now I won't discuss about field first, because let me make it the charge and the force very clear, because Coulomb's law starts with force, and first we'll know about force. And what is force? Is it a vector or scalar quantity? In junior classes you have done, force is nothing but force is equal to force is nothing but a force applied on something. So if you want to call it ma by second law, this is vector, so this is also bound to be vector. You can't get rid of this to be considering as vector. That means force is a vector. It is having defined direction. By saying vector, we only mean one thing, that is having a defined direction. So we are starting with a charge and a force exerted by that charge, but a question comes, who will experience the force? It is of course not you and me. Some unit charge will experience the force. And if we have some unit charge here, suppose a test charge whose magnitude is unity, and that is being imposed on this charge, and then this unit charge q naught will face that force, and that force is interpreted according to our mathematical notations. So if now I can easily say with some particular rule, some particular pattern, this q naught will be repelled or attracted. If it is positive charge, then it will be, and if this is also positive, such charge Q, then this will be repelled, and if it is negative in nature, then this will be attracted, but it will be facing a force, and force is in 3 dimension. So I can consider the force to be x, y, z, function of x, y, z, 3-dimensional function. So if I consider that to be 3-dimensional function, I can split that into I fx x, y, z, I plus j f y x, y, z, and k f z x, y, z. Now a question may arise in your mind that why I am taking this fx to be a function of x, y, z. Now who knows in the space which point is what? Try to understand me. I have a point here. This has got its xyz component. I have a point here. This also, this is defined in your so-called fz direction, but this also has got its xyz component. In general, it's always wise to consider xyz. If something is missing, then we'll consider that coordinate to be 0. If it is strictly lying on x-axis, then we'll call yz to be 0, or vice versa, so and so forth. Means we are taking general equation of the 3 quantities in the Cartesian coordinate system. Now in this figure you can see, if lines of forces are coming like this, you can see there is a curve. So actually our target here is going for vector calculus. To understand vector calculus, these are the prerequisites, and we have to understand. Right now I am not going according to syllabus, because initially 2-3 lectures I have to give only on the beginning, and then I'll go according to syllabus. So this is how you talk about your concept of vectors, vector functions. Now I'll go to your typical known factors. For example, I have taken 2-dimensional because 2-dimensional seems to be much easier for you to understand, because that is in one plane. So with one plane our concepts are much better, so I prefer to take one 2-dimensional concept. So here they have taken one 2-dimensional concept, like here this one, fxy only, and ix plus gy. Meaning is very simple. I can plot this in the graph. Please listen to the interpretation, because at the end of this lecture I'll give you some notes, numericals, and you have to solve them. I'll solve them in the video after a certain time. I'll solve them and upload them, but after a certain time, after you try and contact me. So this is my x-axis and y-axis. Suppose this is my x-axis, this is my x-axis, and this is my y-axis. I hope you understand. So I is somehow, maybe x is equal to 2, so you have 2 units, you know how to split it, and maybe y is equal to 3, so I have 3 units. So vector will be somewhat here. You can consider the vector to be here, somewhat here. If this is my y and this is my x, so I'll consider vector to be somewhat like this. Now whatever it may be, ultimately you come to a conclusion that you can plot this graph. That means between 2 points in 2 dimensions. This is a figure you can see. If you have a charge and all the forces going in all directions, the previous diagram I showed, that is also showing exactly the same figure, but that is in 3 dimensions, and that is more real. Remember, you cannot have actually in real world any function which is force and of electrostatics world. It cannot be only of x, y. It will be never in a plane sheet. It will be in a 3-dimensional figure. Now why I am saying this, because this figure, this constant, we are taking for 3 dimension, because 4 pi is representing 3 dimension. So this is my typical Coulomb's law, and when you take this q naught down in that means when this force, see I have written here er means function of r. Of course electric field is function of r. If you have charge here and this is my r increasing, that means r is the changing factor, like the function equation in previous case. Right now I've been showing you, you are saying that if r changes, E also changes, electric field changes. So E electric field is no doubt a function of r, and in that case also force changes. Here we have taken force also to be equal to function of r. So force r, Fr, and you writing this in 2 dimension, Fxy is equal to Ix something, it's the same thing. You can also express this Fr in terms of r is equal to what? In this case, r is equal to, this is a vector, remember, ix plus jy. Please try to understand this, ix jy. So I can consider this to be in vector formation. It's a good option to obtain electrostatics properly in the vector notation, and this is my q naught, which is experiencing the force and for which we have this. That means this is equal to this. We have done nothing. And unit vector is showing the direction of the resultant, because vector can be equated to vector, vector can be equated to vector, all the things should be vector, that is for sure. Now let's consider, suppose we have two charges, one is q and somewhere q, and we have q1, q2, q2. This is in my previous class 12 videos also, you'll find same thing, because I normally give two basics in class 12 so that they're very comfortable in higher level and for entrance. So suppose we have two vectors like this, and this is my q naught, which is experiencing force for this. So what do? We take vector like this. So this is my one vector, this is my another vector, and between this also we have some vector. Suppose they are positive, so we consider this one. So we can use triangular law in this. So this, and say suppose this is my r1 and this is my r2. Say suppose between them I have a force F1 and between them I have a force F2. If you add up F1 and F2, you will get to this. Suppose I call it this F. So you can say by using triangular law, F is equal to F1 plus F2, because triangular law says this. So I can simply say F1 is equal to F1 plus F2. Very clearly I have mentioned this. So that means only this is representing all. So we are using the same concept, only Q and Qi. This is the example I am showing you with only one and two charges interfering with superposition theorem, which call it, with Q naught. I have n numbers of n number of charges, then I can easily consider like this in summation, and the distance is nothing, r minus ri, because whatever you can see, if I have considered here vector as force as a vector function, and I can consider same as r, this is r1 and this is r2, this is r3, same story will happen, and in r you get a structure like this, because distance is distance, and main ri, any r, whatever ultimate value you have, you get difference of these equal to this. So because you are concentrating to this distance, and this is nothing but this minus this, so you concentrate. Please go through this in junior classes, you have done all these things, I won't go into details of that, and then you come with this, ultimately we come to this. Now one thing very interesting arriving here, that we talk about this electrostatic field R. This is very much known in 3 dimension. We can consider this, and we ultimately can interpret this as a function of this. That means E is a function of R, and we can interpret this as a vector function. That means now we are very sure that electrostatics force, that is Coulombic force, is nothing but a vector function, and electric field is also a vector function. I am not here discussing potential. Obviously next step would be the potential, and we'll see how it works in some other topic, because we'll come across along the system. Now let's discuss a very important term here, average charge density. Average charge density is the charge per unit volume. So you talk about, this is my symbol of average charge, Q, del Q by del V. Now if I go to understand this as a function, this is not a vector function, remember this, we are talking about scalar function in this. This is also a function, we also have scalar function, and we have rho x, y, z, because we are dependent now on the volume. Del V is the volume, this is volume. So we are talking about the charge by volume, and if we give a limit to del V tends to 0, then we are bringing this in the calculus form, differential form or integration form. You all know this. If you have doubt, you can see my mathematical tools of class 11, that will make your concept much clear. And remember, these are not, don't think them to be underestimated, because of 11th lectures, they are equally important for even BSc or BTech students. So don't misunderstand them and don't underestimate them. Now these are the basics. With this we can say If this is the case, then we can consider this to be in this form, del v with its limit taken that side. Now this is a typical division. This is not yet. With this we can make equivalent of the differential form, but till now this is a typical division. This is not ddt or ddv of q still now. Now if we take this, this will turn to q. Integrating del q, we can get q is equal to volume integral of this. Here I would like to bring reference to the meaning of volume integral. Suppose I have del x. This is my only line integral. I integrate the line. You see please the mathematical tools, and if I take double integration like this, del x del y, this is also surface integral, and we also call this as surface integral like this. I can consider this to be like this. And if I have 3 x, y and z, so dx, dy and dz, I can consider this to be my volume integral. So I'll consider this to be like this. There's a v symbol and dv. So they are using that concept. There are 3 integrals indicating 3-dimensional integration, and that is being done with electric field, that is a vector quantity, and I have replaced q by this. In junior classes you have used this technique, but not like this. This formula is one of the crucial formula you are going to use for everything, so please take a serious note of this formula. This is one of the crucial concepts you have to understand all throughout the syllabus. So here you talk about integration of what? Density, charge density, average charge density by distance square and del v. So this is what you have electric field is. So what we have done actually, electric field is, see, we are comfortable with x, y, z. We are very much comfortable with x, y, z, but we are not comfortable with electric field, because with our senses we can sense electric distances, geometrical distances, but with our senses we cannot sense electrical field within coordinate system. So what is our try? We are trying to convert electrical function, vector function, as a geometrical function with distance and of course average charge density, which can be calculated in lab condition by knowing volume and amount of charge. We have typical device in junior classes you have done, electroscopes, by which we can easily calculate our charge, or by capacitor formula you can easily calculate our charge in lab condition, and you can measure volume, and with this formula you can easily calculate out electric field in the vector notation, maintaining without touching, without disturbing the vector notation. This is the fun. Now because this topic is highly mathematical intensive, but in the beginning if I go highly mathematical it may be a bit confusing for you, so it's not advisable to go for the mathematical concepts. For the books, reference books, I have used many, so some other time I'll give the reference name, and you can use follow any book as you want. It doesn't matter much, but the concept should be very clear. That is very important for you. Now let me discuss some problem. This is a task for you, and you will record this and you have to answer them accordingly. In some other later phase of time I will discuss these questions to you, and now I'll give you some hints on these questions. They are saying, using arrows and proper magnitude and direction, sketch each of the following vector functions. So this is one function. Answer will be in terms of x and y, remember this, and this is interpretation. You have to interpret this, what they want to say. Very simple actually, they're very simple. This is to make you habituated to the interpretation of the vector notations, mathematical notations in real life world, because I am not teaching you mathematics, and we are using mathematics to understand physical world or application. This is typical electromagnetic theory. So these things, if this vector notations interpretation are very clear to you, you can easily, many of you I'm sure you can easily answer D, you can easily answer J. This is going along. I'll give you a hint that the direction, this is in the 8 quadrant system, so which is plus, though this is in 2 dimension, only x, y has been used. The same type of question can be asked in 3-dimensional concepts, and you have to locate exactly where the vector lies in the coordinate system. Same thing here. This f seems to be a bit complicated, but this is also very simple. you know magnitude is the square root of the square summation of the square. So you can easily find out what they are talking. Indirectly, in various methods, they've asked you only same question in many cases. X and Y is not equal to 0, of course. Now I may ask you another question. In case X and Y equal to turns to equal to 0, then what do you expect? What will be the vector turning to? That is a very crucial question and very critical question. You can think about it. And then IY, this is another one, all similar type. Let me go to question 2. Using arrows, sketch the electric field of a unit positive charge situated at the origin. You can do that. I don't need to electric field positive charge situated at the origin. So which way the electric field will be moving around the origin, that you have to find out. Now you have to draw. Write a formula for a vector function in 2 dimensions which is in the positive radial direction and whose magnitude is 1. Very interesting question. Write a formula. You have to write a formula for a vector function in 2 dimensions. You have to write the formula in 2 dimensions which is in positive radial direction and whose magnitude is 1. Then last question in this lot, write a formula for a vector function in 2 dimensions whose direction makes an angle of 45 degree with x-axis and whose magnitude at any point x and y is x plus y whole square. This is all are very simple questions in almost in 2 dimensions. They have not used z direction anywhere in the whole concepts. So initially I cannot give you very tough questions, so I'm giving quite easy questions and I expect you will be answering them very comfortably. Thank you for today. I'll very quickly come with my lecture number 2. Thank you.